Hello and welcome to Engineering Economic Analysis. This is the first lecture of the class and it is all about the engineering economic decision-making process. So what we're going to look at right now is how do we make decisions from an engineering point of view and what's your role in making these decisions as an engineer? And looking at them from the principles of making good decisions on an economic basis, because it's engineering economics, even though there are other factors that will always play into the decision-making process, such as just simple personal preference, or also things like political issues or ethical issues that come into play. Now, there is a technique for doing this. It isn't just that we go out there and say, hey, I want to do this and I've got a way to do it. We try to quantify the decision-making process. Now, it isn't that easy, because the decision-making process is looking at an economic comparison between alternatives. And alternatives of things that you're going to do are based on a number of factors. Well, one, it's based upon what you know from past history. That's how you get numbers. You've got to actually quantify. And usually the way that we quantify is in terms of dollars. But you've got uncertainty. Okay, you are predicting something that's a decision that'll affect the future, but you don't know the future. So what you've got to do is make the best assumptions that you possibly can to put together the best decision. Uncertainty, risk, and estimates of the future. What's going to happen? So what are we trying to answer? Well, if you're an engineer, you're probably going to be working on projects. And the projects are going to be prioritized. Projects that you're going to do now, projects that you're going to do later. Projects that you're going to do now can take on a number of roles. One is, hey, this is going to make us a lot of money. Let's do it right now. Or if we don't take care of this now, it's going to become a real problem later. We should probably do it now. There's a number of reasons why we make decisions the way that we do. But from the 30,000 feet, are we going to do this or are we not going to do this? Those are some of the factors. Now, as you get down to, we're going to replace a piece of equipment. Now you're starting to make real decisions about that piece of equipment. What piece of equipment should you buy? Should you buy so we're going to talk about how we analyze all this. Now, you do this. You make personal decisions all the time that affect money. Should I buy a house? Should I rent? Well, what goes into that decision? Most people would say, I'd like to buy the house, but then I might be stuck with a house that I can't sell. Okay, that's a decision of something that could occur in the future. Should I rent a house? Well, renting might get you out of some maintenance costs and other costs that are down the line, but you have to have money up front to do it. And if you don't have money up front to do it, you're not going to have much success in doing the buying of the house. That good old down payment, which you don't need on rental. So we've got alternatives there. In the example of buying a house, we have alternatives. And we can look at the decision criteria. Can I come up with the money? Okay, and then you make a decision. Sometimes that decision is really made for you. In the example of buying a house, that decision might just be the only feasible decision is to rent. But at the same time, maybe they're all feasible alternatives, and there's not just one house or rental property on the market. There's multiple. So that's personal decisions. So what do? First, just what's the problem? Okay, the problem is I need a place to live. Define goals and objectives. I want to either buy or rent a house. Put together the relevant information. What's this going to cost me? What's it going to cost me in monthly? What's it going to cost me up front? And what is going to be my downstream effect of all of that? Like, if I buy a house, will I be able to sell it? If I sign a lease, will I be able to get out of it? Okay, those are. You look at the alternatives. You look at the decision-making criteria. In the case of personal decisions, will be personal. Maybe you can live a little bit tighter so that you can get that down payment together. You look at the alternatives, and then you make a decision. And hopefully, you'll learn from that decision. So let's look at how you could do this. first. Okay, every problem has alternatives. And one of the alternatives is always don't do anything at all. So once you've identified those alternatives, look at how it's going to affect two things: cash in hand, but really cash flow. It's all about, in the engineering world, about making the solid economic decisions. So what's it going to cost me? How much I've got to make off of it. That's really what it does. Now, as we go through the semester, you're going to learn about how to get those numbers and put those numbers on equal footing. So that you're not comparing apples and oranges, you're comparing oranges to oranges, or you're not comparing dollars 100 years from now with dollars now. And that means you're going to have to understand the time value of money, but it also means you have to deal with interest rates and also understand worth. And that is a real complex one also, because if you're working in the technology world, something that's worth a whole lot right now might not be worth anything 10 years down the line, even if it was brand new. Okay, so I didn't say it was going to be easy to make the decisions. I just said that you had to make them. So, okay, simple one right here. It's easy to look at. You've got a machine in your factory and it stopped working, and you need that machine to keep the factory running, so you need to replace it. So what are you going to do? You're going to look at all your alternatives. One of the alternatives is always going to be to buy a new one, and you've probably got multiple choices there. Another one is to repair it, and you probably got multiple choices there. Do you do a long-term repair to make sure it works really well, or do you just patch it up really quick? You're going to look at the cost of all those different things and what you're going to get out of them, and then you're going to make a decision. See? It isn't that hard. Well, kind of isn't that hard. There's other examples that are like big ones, like big government projects. We need water. We need water for the people. Okay, what do? Do we take water from a surface source? Do we take water from a ground source? Okay, you know that you need the water. You know you need that, and you want it for either, well, basically increased usage. Population growth, could be factories that need water. Do you dig a well? Do you take it from a surface? Both of those have different kinds of treatment. What level of treatment do you have to have? And in the case of water systems, there is a political component other than just an economic component, because it actually wouldn't be that hard to make these decisions if it was purely economic components. And you've also got to look at what you're capable of doing in this situation with water. Can you take more water out of the ground? Can you take more water out of a surface source? Either way, you're going to put all of this down. You're going to quantify it, and you're going to make a decision. When I say quantify, you're going to quantify in the terms of dollars, the cost. Simple one. Do I rent, lease, or do I buy a car? And in which case, what car do I buy? So suppose I say you've got $25,000 on hand. Well, you don't have $25,000. You have the ability to borrow $25,000, let's just say. And you go to a car dealership and you get some quick talk. If you're an engineer, you should be able to see right through all the quick talk and make a good decision. But let's just say you start with a certain amount of money and you want to make the best decision that's going to cost you the least in the end and get what you want to get done. Okay, now, car, highly personal decision. You may be able to get a $15,000 beater that's going to be reliable, or you might turn around and buy a $45,000 car that makes you look good. Hey, it's part of the decision-making process, but the concept between purchasing and leasing a car, that's something that you can actually quantify, and you will be doing it later. So here's the thing. You're going to be making these decisions based on what you know right now, or what you can gather to know right now. Most of these decisions are going to go well into the future. If you're building a building, okay, a building, they last for a while, and those decisions will actually have an impact into the future. Suppose you're assuming that you can lease business space out to other businesses in a building, well, you know what might happen? We might have a pandemic, and people might decide that they no longer want to use office buildings. So maybe you learn from the past and say, I'm going to have an office building that I can repurpose into housing. Hey, those people who watch the news, these things happen all the time. Your role, okay? You're going to be working with others when you make these big decisions. It's not your decision. But if you are the engineer on these decisions, it is your role to understand the cost associated with alternatives that are technical alternatives. What does it cost to build something? What does it cost to manufacture something? And what are the costs of the different alternatives in building something? Okay, what's going to cost for putting the equipment into there? Okay, you need to know these things. You also need to be able to justify these things, because you're going to be getting money, and you're probably going to be getting that money by borrowing it, and you're probably going to be borrowing it over a long period of time, and you need to know what that actually means. You know, I can sure, people don't give you money, you pay it off. So you have to look at that, and then you have to look at what, if you're working for somebody, what effect does that have on their viability? Okay, you hear the term over leveraged. Hey, that means you borrowed more money than you have the ability to pay back, or basically your asset to, your asset ratio is not looking good to your liabilities, which the liabilities could be the payments that you have on something compared to the assets that you have. So big projects cost a lot of money, and they are long-term, which means they last a long time, which means that the farther out into the future you go, the harder the future is to predict. So how do you predict the future? Well, you do your best job. How do we predict the future? We base it on what we've seen in the past and the best information that we have right now. So if we assume that our investment will allow us to make more of something, okay, and be able to sell it, that's a good, sounds like a good investment, but it may be something that may not have a lifetime in the future. And you got to be able to estimate not just what it costs to make something right now, suppose you're making something, but what's going to cost to make that thing in the future. So again, I didn't say it was easy. I said it's something that you got to be able to do. So what is all this? It's uncertainty. Well, we have a way to mathematically deal with uncertainty. Okay, statistics is part of how you deal with uncertainty. You can say, hey, there's a 50% chance of this occurring based on our best available information. There's also a 20% chance that the bottom's going to fall out, and there's a 20% chance that it's going to go really, really well. That's dealing with uncertainty. And how does that work? It's good old statistical modeling. So you're going to be working with equations. It is what it is. Some different things that you can do to look at this. Suppose you're in a service industry. Healthcare is a service industry, and you want to increase the quality of your service. That might particularly take an investment, but it might also take just a restructuring. So let's look at some of these. One of the most, well, two of the most common reasons to do something is, hey, can we reduce our costs? That's just company stuff. Hey, we need to get costs down. How do we get costs down? Okay, if you ever watch the IKEA video where they got a dollar sign with two lines through it, and they say, I got an idea, let's remove one of the lines through the dollar sign. Hey, only need one. Didn't reduce any cost, but it was funny. So anyway, or you have to take care of obsolete equipment. So service improvements. Let's talk about just a simple example of service improvements. Suppose instead of buying jeans in specific sizes in a store that are already laid out, which they may or may not have, we simply take a set of measurements and produce them custom to order. Is it worthwhile? Will it make money? Is this, I mean, are people willing to wait for the jeans to be automatically be produced? Okay. Hey, there's a cost. You got to have the equipment to do these things. There's also another side. Will people actually do that? Or another service industry. Okay, here's good old healthcare. You guys go to the doctor, or to, we call it service provider, or the doctor goes to you. Okay, which one works the best? You can't say that you going into the doctor's office is the most economically viable alternative because you haven't considered all the alternatives. And you have to sit down and look at that. So if the service provider visits patients in home care, which is definitely a thing, okay, but those are economic decisions. And the economic decisions can easily be based upon what the customer will accept. If you are willing to pay a little bit more of a premium for in-home care, which you do, it does make good economic sense. So let's look at just a simple example here. And I like this example. It's really kind of hard to read. But here's the thing. You got a part. It can be made out of plastic or steel. Okay. Now, taking aside the part itself of whether it lasts longer being made out of steel or being made out of plastic, okay, the materials cost different amounts. So in this case, the material cost of the plastic is more than the steel, okay? But the upfront investment for the machinery for the steel is higher than for the plastic, okay? And you can make the steel faster than you can make the plastic with the equipment, but the equipment costs less. Okay, all of those numbers, as an engineer, you have to look at that and break that down to one number to make that decision. There is a way to do that. Now, there's some things that we do need to know, like such as what we know the cost of the machinery, but how long does the machinery invest? I mean, how long does the machinery last? And how often do we have to retool it? And how long, okay, so we've got cycle times, minutes per part, which means you can make more steel parts than plastic parts in the same amount of time, but does it even matter? Because maybe you can run the plastic machine for a longer period of time than the steel. Okay, again, those are the pieces of information you need to have to make a good decision. Just from this 4 pieces of information that they have in this material selection. And that's not the entire bit. So, equipment replacement. Again, something that you do. When do you replace an old piece of equipment? Do you wait for it to break and replace it? Do you do a projected lifetime and then replace it at that specific life, even though that piece of equipment may have a much longer life ahead of it? Maintenance costs money. Can you maintain it and keep it up and running? What effect does it have on everything else that it might be tied to? Because it's usually not one piece of equipment in a plant. There's usually many. And you make a decision on all of these. Okay? And we'll talk about some of those in the future, but you're going to talk about those. You're going to research this. You're going to look at this. You're going to look at real live cases and make decisions. Okay? New products. Okay? You've probably heard the concept of planned obsolescence. Hey, Apple was really good at it. Their iPhones. Hey, is there anything wrong with the old iPhone? Absolutely not. We're going to put a new one out every year and make sure that people want to buy that one and get rid of the old one. Okay, will people want more of something? Do they want a new product? Are they going to want more features on a product? Are they going to be willing to spend more money for those features on a product? So let's take a little example here. Some of you probably shave. I do, even though I don't shave this. But my free project, Gillette Company, $750 million investment, $300 million in product promotion. It's more expensive than the old razor. A lot of questions associated with this. Okay, you had to put the money in, you had to make the things, but you have to charge more to get that money back. And okay, so are people going to be willing are we going to have a drop off in sales? Because if you have a drop off in sales, what effect is that going to actually have on the investment that you put into it in the first place? Or maybe we can pick it up through promotion. Is it going to be accepted? I mean, do we need 3 blades, 4 blades, 5 blades, 27 blades to shave? I mean, okay. Believe it or not, that actually gets tied into psychology of shaving. All right, so cost, and automation. Okay, people cost money. Equipment costs money. Okay, here's a decision you make all the time. What can we automate? Okay, and why do we automate? Maybe we automate because we can't find people. A manual job, you simply don't have the people to do it. You look for automation, but that costs money. Okay, again, decisions that you make. Now, some fundamental truths. I love these fundamental truths. They're economic truths. A nearby dollar is worth more than a distant dollar. In other words, $1 today is worth more than $1 tomorrow. Okay? Differences among alternatives, and you can't spend more than you make, and you don't take risk unless you got some sort of return that's expected. I mean, that's it. Think about that. $1 today is worth more than $1 tomorrow. Okay, you look at differences amongst alternatives. You got to make more than it costs, and you don't take risk unless you got an expectation of a return. There it is. Okay, today, later. Okay, now here we go. All it counts is differences among alternatives. If something in the alternatives is the same, we don't care. Okay, you got to make more than it costs. And marginal revenue, what we're talking about is, in many cases, it's a per unit. But then again, this is on what we're assuming a manufacturing situation here. But the marginal revenue must exceed marginal cost. This is true of every situation. And okay, you do this. Risk is not taken without expected additional return. In other words, are you going to put your money into something risky like stocks? Or are you going to keep it in savings, which has essentially zero risk, or bonds, which are fairly low risk? If you don't have an expected amount of money that you're going to make that's higher, it's not a good decision. So here you go. Let's summarize. Engineering economic decision making. You will be doing this. This is part of the job. Okay? We're looking at 5 types of engineering economic decisions in this class. You may have other ones that occur, but what we're doing right now: service improvements, equipment and process selection, equipment replacement, new product and product expansion, and cost reduction. You need to understand uncertainty. You need to understand the costs, the time value of money, the risks associated, so that you can define a good investment. All right. Hopefully your head is swimming with all of these great new things that you've probably thought about in the past, but maybe not. But this is part of what I expect to see. And if I said something about, if you watch this video and you heard me talk about something that you need to consider for a specific type of decision, and I give you an assignment that says you making those decisions, you better start thinking about how you're going to quantify those things. Now, I'm going to obviously get you more into that, but hopefully this is the real thing. This is what it all boils down to in the end. Thank you. This is Dr. Ron England signing out from Engineering Economics. Have a nice day, and we'll see you some point during the class.